Alright, problem number 11 reads that I must first solve for x, and then I must determine if line A is parallel to line B. Alright, so nowhere in here does it tell me that any of my lines are parallel, so do not assume any of the corresponding alternate interior angle stuff. Don't assume any of it, because you're not given that the lines are parallel, so I don't know any of that to be true. Instead, use things that you do know are true. Things that don't involve parallel lines. Because you don't know they're parallel, use things that don't involve parallel lines. So for example, just focusing on the right hand side of this problem, these two angles, 2x minus 30 and 1/2 x plus 15, well, those are vertical angles. Those have nothing to do with parallel lines, so I'm not going to bother. I'm just going to set those equal to each other because I know that vertical angles are congruent. 2x minus 30 is equal to 1/2 x plus 15. And remember, again, I'm setting those equal because those are vertical angles. I'm not assuming anything. I'm using what I know to be true. Because of this fraction right here, I'm going to go ahead and multiply everything by 2 in the problem to get rid of the fraction. So right now I have 4x minus 60 is equal to, well, 1/2 x times 2 is just an x plus 30. Bringing all my x's to one side, subtracting x from the right hand side and from the left hand side, I get 3x minus 60 is equal to 30. And then finally adding 60 to both sides, I know that 3x is equal to 90, making x equal to 30. So now I know what x is equal to, and I didn't assume anything about parallel lines. I only used vertical angles, something I know to be true. So now I know that x equals 30, but the question not only asked me to solve for x, but it also asked me to determine if line A is parallel to line B. Well, if line A was parallel to line B, well, I know certain things about parallel lines cut by a transversal. For example, when two parallel lines are cut by a transversal, then I know that my corresponding angles will be congruent to one another. If I were to plug x, basically what the question is asking, if I were to plug back x back in for this angle, x plus 10 degrees, and this angle, 2x minus 30 degrees, if I were to plug x into those, and those were equal, if I were able to get expressions out of this where the two of them are equal, well then yes, I would know that line A is in fact parallel to line B. It's also possible that I might plug x into both of these and find out that they are not equal in measure. And if that was the case, I would know that A was not parallel to B. So if I were to plug in x to this top left angle here, x plus 10 degrees, I would find out that that angle is a 40-degree angle. Plugging in x for this angle to the right of it, well, 2 times x is 60 minus 30, 30 degrees. Well, here I have corresponding angles, but they have values that are not equal to one another. 40 degrees is not equal to 30 degrees. Because these two values are not equal to one another, and corresponding angles are supposed to be equal if the lines are parallel, then I know that A, line A, is in fact not parallel to line B. A is not parallel to B because my corresponding angles are not equal in measure. Number 12 here does tell me that these lines are parallel, so I can use all the facts that I know from parallel lines. But, however, I'm not only solving for x in this problem, but I'm also solving for y. So it looks like I need to set up a system to solve for x and y for my two unknown variables. Well, I'm going to start down here on the bottom half. I know if I have two parallel lines and they're cut by a transversal, then co-interior angles are supplementary, meaning they add to 180 degrees. So first things first, I'm going to write out the equation that I know. 2x plus 5y is equal to 140 degrees. Oh, that's not true. I apologize. 2x plus 5y plus 40, 140, is equal to 180 degrees. Okay, let me go back through and show you the mistake that I made that you should not make on your quizzes and tests. What I did is I looked at this bottom angle and I said, well, that's equal to 140 degrees. That is absolutely not true at all. Disregard everything I said. Instead, know, because you are an excellent student, that 2x plus 5y plus 140 degrees, the other co-interior angle, the two of them together are supplementary. The two of them together add to 180 degrees. Well, I'm going to go ahead and set that equation to the side, and I'm going to subtract this 140. Whenever I work with systems of equations, I like it to look nice and simple. 2x plus 5y, and subtracting 140 degrees leaves 40 here on the right hand side. Remember, if we've done systems before in class, that I kind of like the columns x's lined up with the x's, y's lined up with the y's, and the numbers on the other side of the equal sign. So I don't like this mumbo jumbo over here. Now here we're not going to make the same mistake again. Looking at these top pairs of angles, they are also co-interior angles. Because these lines are parallel and they're cut by a transversal, I can say that my co-interior angles are supplementary. So here I know that 4x plus 5y, now I'm going to add my 130 degrees. The two of those added together make 180. So again, I'm going to copy down this equation, 4x plus 5y, and in this case, I'm going to subtract 130 from both sides and set this equal to 50. Now this is fantastic because here I have my columns of x's, I have my columns of y's, and they happen to have the same coefficient, which makes things tremendously easy. And then I've got all my number values on the far right hand side, on the other side of the equal sign. In order to solve this, all I have to do is multiply one of the two of these equations by -1, because when I'm solving systems of equations, I need not only the coefficients to be the same, but one opposite the other. That means if one is going to be positive, the other needs to be negative. If one's going to be negative, then the other needs to be positive. In this case, I have two positive 5's, 5y's to be exact. I need one of those to be negative. So I'm going to multiply this whole bottom equation by -1. So rewriting those two equations, 2x plus 5y equals 40. That top equation doesn't change at all. The bottom one, now everything's going to be negative or negated. If it was negative before, it'll be positive now. But everything's positive, so it's going to become negative. Negative 4x minus 5y is equal to negative 50. Now here, it's just going to be a straight up addition problem. I'm going to add everything in its columns. 2x plus negative 4y, remember I'm adding this whole bottom row. 2x plus negative 4y is negative 2x. 5 plus negative 5y is exactly what I was looking for them to cancel out, so no y's remain. And this is equal to 40 plus negative 50. 40 plus negative 50 is negative 10. So negative 2x is equal to negative 10, leaving my x equal to positive 5. So I've solved for x, and now I need to go back and solve for y. Plugging in x into either of these top two equations, I'll do the top one. 2 times my new x value that I know, 5, plus 5y. Here I'm plugging in x to this top equation, 2x plus 5y equals 40. 2 times 5 plus 5y equals 40. Leaves me with 10 plus 5y equals 40. Subtracting 10 from both sides, I get 5y equals 30. So y must equal 6. 5 is x and 6 is y. And I verify by going back and plugging them in, hoping to get 180 degree co-interior angles added together in both of these. If you have, then you've done this problem correctly.